Hello everybody, welcome to the second module on exploratory data analysis, where we'll be looking at graphical representations to visualize your data. So let's start with stem and leaf plots. So as you can see, you have values for beats per minute from 85, 85, and 88. In the 90s as well, from 90, 92, 92, 93, 93, 94, so on and so forth. Sometimes you might want to remove the stem which has no values associated with it. For example, the 160s out here. For that, you can use the function of prune. There you go. So you can see that Stata has dropped the stem associated with the 160s out here. Sometimes what you also might want to do is split your leaf in case it's getting too long. For example, the beats per minute in 90s out here. So for that, what you can do is specify the number of lines you want each stem to have. I would like 2, so I'm adding 2, and I'm going to ask it to prune again. So as you can see, Stata divided the beats per minutes in 90s, in the 100s, in the 11s, 13s, 15s. They divided them into 2 lines because it had values from 0 to 4 as well as from 5 to 9. Stem and leaf plots are a practical way to look at small data sets, but as the data set increases, it loses its practicality. A better way of looking at the data are box plots and histograms. So let's look into that. So let's do graph box beats per minute. So these are known as box plots. As you can see, it's a right skewed distribution similar to your stem and leaf plots. There are no outliers present in this diagram, no extreme values. So this value out here would be your minimum. This is your Q1, this or 25th percentile. This is Q2 or the median or the 50th percentile. Out here, that's your Q3 or the 75th percentile. I can say that the distribution is right skewed because the median line is shifted down and is not present at the exact center of the box. But no matter how big the box is or how where the median is present, Q1 to Q3 will always contain 50% of your data. This whisker out here represents your maximum value since no outliers are present. Let's look at something which has outliers. Okay, let me try length. Yep, it has some outliers. So automatically these outliers become the maximum value with the one at the top becoming the maximum value. And these are all extreme values. To identify these outliers, you might want to label them. Let's do graph box length. And then you want to label them. So mark 1 and label. And let's say I want to know which singers are associated with those songs. So I'm going to put artist name. Now you can see that these 3 outliers are labeled with the singers, with the name of the singers. You can choose any variable you want. You can choose ID. You can choose to label them with the track name also, depending on how you want to look at the data and what questions you want to answer. Sometimes what you want to do is you might want to drop these outliers altogether from your analysis. So what you would do is graph box length, and then you would specify no outsides. So you can see that all the outliers have been dropped from the graph. Another thing you can do with box plots is compare the distribution between groups. So let's look at graph box length, and let's compare the length of songs between male and female singers. So it's given me the distribution of the length of the songs depending on whether they were male or female, depending on whether the singers were males or females. As you can see, the distribution is pretty normally distributed, but except for a slight right skew present in the graphs. Let's move on to the last topic, which is histograms. So let's look at histograms for a histogram distribution of beats per minute. And I would like to have a frequency distribution. So I'll add frequency at the end. There you go. So Stata provides me with a histogram. As you can see, by default, Stata considers the values as continuous rather than discrete. It's something we'll get back to later. But suppose you would like to visualize this histogram in a better way and look at the distribution in a better way, what you can do is add a curve over the histogram with the function norm. It just helps me visualize the distribution better, and I can say for sure that it's a right skewed distribution and it's not normal. But coming back to this assumption of Stata that it's a continuous distribution, you might also want to specify that beats per minute is a discrete value and not a continuous distribution. So I'm specifying that it's discrete. The other graph definitely looks better. It's not as pretty, but this is definitely more accurate than the previous one. And similar to box plots, you might also want to visualize the data to compare two groups. So again, let's compare male and female singers. The bars for the male singers were higher because there were a larger number of male singers. So obviously they had a higher number of songs in according to the beats per minute. You can also see that both male and female singers didn't have any songs between something about 160 to 170 beats per minute. And of course, that both distributions were right skewed. Yeah, so that brings us to the end of the module. We looked at some useful codes like describe, codebook, summarize, tabulate, sorting the data in descending or ascending order, list, and then we also looked at some graphical representations by using stem and leaf plots, box plots, and histograms. This is not the be-all and end-all for exploratory data analysis, but I hope that you are confident enough after this tutorial to start with your analysis on your own. Thank you for your time and hope you have a nice day.